Thank you. Hi, everybody. Nice to see you all. You guys are the self-starting teachers who come on your own accord. Is that right? In the middle of the summer? No extended hour pay yet? None of that? You guys are the best kinds of teachers. I've spent a lot of time working in education. I'm going to talk to you in a minute about that. Before I do, I've got some handouts, so it's a little manipulable so you can sort of see what we've done. Could I get a little show of hands? How many people have done paper circuitry before? A few. Okay, that's actually great. So I've got a few things here, and I'm going to, you might, hopefully by the end of the session, you'll know just what these things are. So I'm going to put them on the different tables. You can kind of move them around, and as we talk, just share them out. This paper circuitry and design thinking. Got that? Okay. You'll notice the form and a little bit of improvisation we do here, so I'm going to drop that here. Okay. And just, you can take a look at it, nothing required. The next one is a simple paper circuit exercise. At the end of the session, I'm going to talk about a thing called Hack Your Notebook, which is this little project. And if you've not done a little paper circuitry project, you can check out these two and kind of circulate these, all right? That will go with that. And the third one, I'll start over here. You guys will get something coming to you. This is actually the R&D that we're doing for open data, open minds. We want to be able to pull live data from communities onto paper. That make sense? And what we're looking at here is an example of that. And we'll talk about this later in the deck. But you'll see that we've got a book here that's cycling LEDs, and it's pulling Wi-Fi signal. And this, as we'll talk about later, is a book about the San Francisco Bay. It's a very fragile handmade book. It's a prototype, so be careful with it. But you can check it out, okay? The way I'm going to do this today is I'm going to talk to you about a bunch of slides. I'm going to give you some pictures and some images to see, examples of what we've done over the past 4.5 years with this work with paper circuitry. And I've got a series of videos in here as well, so you can get a feel for what it's been like to work with teachers and some kids. All right? Sound good? So here's a story about me in a nutshell. Think of that as a CV of sorts. I'm a humanities person. I'm an English major. Absolutely. Just goes to show humanities people can teach, can get involved in electronics. I did a lot of humanities. I started with a BA. I was tired of words and relational things, and I threw myself into materials, and I built boats for a while. And then I went off and taught high school. And then I was tired of high school and the bell schedule, and I went back and built more boats. These small wooden boats, some of them larger, and I was in an apprenticeship situation at a school for wooden boat building. And then I went back to graduate school, and I stayed in graduate school. I taught my way through graduate school. I got an MFA in writing and an MA in literature, and I spent a number of times teaching undergraduates comp and fiction writing and all kinds of things. I did that. And I was in Seattle at the time, and then I segued into tech. And I went to work at Microsoft as a vendor. And if anyone spent any time working as a vendor in tech, you know what that means. You're not an employee, but I was a vendor, one of the sea of people at Microsoft when I was in building number 8. So you can picture that. There's building number, God knows how many now. And I went from there into publishing. I worked for Pearson, which if you guys know, the large education company, I worked with Pearson through the dot-com boom on their internet side, and we did a lot of the content management, content transformation around platforms, and creating internet-connected materials from textbooks. And you all know the business models that go into books and textbooks and testing and all the rest. And I was on the internet side of that, watching these markets and these practices and these materials and these tools develop. And then from there, I began to work in what I guess would describe innovation and creative learning with a focus on teacher training and college and career readiness. And I've been doing that ever since. Whoops, I went back. And so the question is, how do you get from that big list to this? This is what I'm looking at now with colleagues on literacy, technology, craft, and open data and community. And hopefully by the end of today, you'll get a sense for how we're navigating this through materials with paper circuitry. Sound good? Okay. This is the picture, is the prototypical picture of what we're setting out to do with paper and electronics. That's a Moleskine notebook. That's a AT-Tiny microcontroller. It's some copper tape that's been soldered. Those are conductive thread leads. And that's a kind of mashup As a writer, as a teacher, as a person focusing on literacies, I thought to myself, there are two platforms in a classroom. One is a notebook. We have centuries of know-how about how to navigate pages left to right or right to left, depending where you're from. And we have about 40 years, maybe, of thinking about silicon and screens in the last 20. And surely they belong together. And who do they belong together for? In my mind, there's a huge opportunity for grades 3 to 8 to take the craft and the materiality and the materials that go with assembly, bricolage, montage, collage, artwork, and engage it in integrate electronics. And so this seems like a low-cost way to reach a lot of kids and a lot of teachers at a particularly important point in the learning ladder. Kids do Python and JavaScript and do IoT devices in high school. That's great. How did they get there? Did they have a fundamental experience at grade 3? I think those kids and their teachers are a place where you can get a lot of value and a lot of important experiences. And so we go from that. This is the kind of thing we're doing now. And this just plays on a loop, but this was for a workshop we did at Carnegie Mellon University in Pittsburgh. And we're working with a chip. You can see it there. It's got a clip on it. It's called Chibitronics. It's the Chibi chip. We work with a company called Chibitronics, founded by Ji Chi at the Media Lab. And we are able to combine computational information with circuitry. Okay? And we'll get more to this in a moment, but we like to work with maps as the interface because maps have a profound amount of information, and they invite a lot of response and creativity. And so what we're looking at there is we're programming the lights to reflect a certain piece of information in our community. And I want you to hold that thought, because that's all about designing, creating, constructing, and connecting to the outside world. As a teacher, I want to share with you a key rule. Whenever I get engaged, I think of things happening in 5s or 6s, and you'll see on that little design thinking panel, it's divided up in 6. But only about 20% of any project really should be spent, in my mind, screwing around with the tech. Do all the backwards planning, think about the organizing, think about the documentation, think about the building, think about the testing, think about the sharing, think about the showcasing, thinking about the review. 20% is going to be spent tinkering and screwing around and having fun with all the code and all the rest. So I'm very much about trying to create a complete experience, which means I have a hard time in schools because people have a challenge giving that much time to the schedule. But I think more and more we're in a place where this is going to be required. Here's a question. How might we bring innovation and invention to our classrooms? This is a workshop we did 2 summers ago at the University of Michigan, or Michigan State actually, with the US Patent and Trade Office. And we were working with that. Could someone hold that up there, right there? I think you've got that design thing. This is the design thinking template we were working with. And I wanted to give you a feel for what it looked like when teachers do this work. So this was the how might we prompt, right? You've all been in a design conversation where you think, how might I do X, right? Well, in this case, it was a week-long immersion. And we were brought in to kind of kick the week off. And we did this exercise. And this is a short little clip of that. Let's see if it'll play.
Assigned to 4 different school districts and then our C2E program. I came from like 17 years of general ed, where I taught bio, AP Bio, 7th grade, 8th grade science. Then I went to special ed and worked with teachers.
Somehow rewarding students for failing. Like failing is part of the process, and you don't get punished for failing.
Right, that's going to take part now.
Explain what your priorities are and how you did that.
Okay, here it is here. Plan learning for experimentation. How need time to plan with all other teachers who would like to participate, create a model learning for all students. Lesson plans for a class project. Children will need to learn how to create. We need to practice the steps to learn how to be successful. Here are the steps that are needed, how many steps are needed for attainment. And when they achieve their goals, they will be able to use the STEM process in all projects.
Right on, let's see that. Okay, let's take a look at what's up front. Talk to me about those stickies.
Okay, the planning. We have to work on that because with little children, you have to have little steps because they don't know anything.
Yes.
Physical activities, what they're going to do when you plan it. And the goal was learning to plan for experimentation. And then we do a project review at the end, which would be a science fair. And I was thinking about retiring. I might stay another year and try to do this.
In previous sessions.
So this was a process that kicked off the week, and it was a combination of an iterative sort of design and planning process. Every teacher created an artifact. Each of these panels, and you can see it when it comes around or afterwards, represented a different way of thinking about the process. The paper circuitry was included as one of those components, so people used the light to illuminate and highlight. So it's all about stacking and layering information and creating an integrated object or product. I've always liked this quote. Just take a moment to read it. I won't read it aloud. Tim O'Reilly and the companies and the publishing houses that he manages, John Brunner used to work for him. This was a quote from 2014. The reason I got into this paper circuitry work has a lot to do with that kind of quote. And I would ask you guys as educators, what's being taught and what needs to be taught? And that's the world we live in now. And believe me, I'm not an engineer, but I watch the skills and the mindsets that are needed to operate in the world these days far outpacing what is typically delivered in a classroom. And as an educator who built boats and likes to make stuff, I'm like, why can't we do that, right? It's not just people who learn JavaScript and Python. These systems and the interfaces for them are delightful, appealing, and getting easier and easier to use. And some of the paper circuit stuff you're seeing is designed to be easy to think about. And so we think about what's required here, and how are we going to start to teach to that? And this is really a conversation about what are the literacies we're focusing on. Literacy as an English person or a humanities person means a typical thing, but I think given the remixing that's going on, the democratizing that's going on, the recasting that's happening with technology and with demographics, the host of literacies that we're trying to promote and teach are changing. And in lots of ways, that's the audience. You don't have to look at stats too far to realize that women finally are on the rise, demographics are changing and growing, and people need to learn earlier, more personally, more creatively. This is a workshop we did at the UC Berkeley in their engineering lab with Scientific Adventures for Girls. And these young girls are doing the paper circuitry work, working with a fine motor skill. You have to kind of right-size the project so kids can be successful. At every step, you need to create experiences that create confidence, that don't create discouragement. Here's another example. This is the Mountain View Library. By now you got that I'm a humanities person. I like notation, I like documentation, we like paper, and we think of paper as a surface and a material that can be extended or augmented. And here the kids are sort of working with the whole idea of illumination. It can look like this too. This is a typical low-cost composition notebook. If you look along the side, this is with a group called the Bay Area Writing Project. Fabulous group that does a really good job of thinking through design principles, language, skills acquisition, and is very good about using tech and digital. But you'll see they've got a fluency prompt, they've got some design goals, there's a whole architecture they've built into that project, and it's the beginning of a culminating activity. Here's another example of some of the templates we use in some of our workshops. Again, you can see the documentation system in the back. And we're using the Chibitronics circuit stickers here as well. And here's an example from a teacher training session where educators were exploring these materials to take them back to their classroom. And I like this picture because we're dealing with all kinds of things here. We have the technical aspects of how to fold tape. Like just that alone is its own exercise. And then we have comments on it. It becomes annotated, and it becomes a playful, interactive. You can make mistakes on that. You don't feel badly about it. It's your thing. You can share it. People can mark it up. It feels like a process. And it also looks like that, right? If you're dealing with middle schools, you can't help but run into that. But you've got wires coming out of a typical book about friends and family. That, to me, is a good thing. That's a nice picture. And it also can look like this. You guys, how many of you guys have kits and maker spaces in your schools? So you're surrounded by parts and devices, and some of that gets used really well, some of it doesn't get used enough. But in our work, we bundle things up so that we can talk about this work. So it looks like that. And it also looks like that. Those are 8th graders in Oakland at a school up near the Chabot, up near the zoo. And you can see on the right, this girl, this was an identity map, and she was laying out a pretty complex circuit and soldering it down. The young woman on the right is doing an elaborate pop-up where she's exactoing out of quite a beautiful little design. This is a good one for you guys. I like working with educators because it's a conversation about scale. You guys, ma'am, how many kids do you see a day? Each day? 90? 60? What's that?
A lot of kids at the school.
Yeah, like how many classes do you teach a day?
I do not teach at school.
After school. Okay, that's one thing. 30 people? Regular teacher at a regular school? 130. 150. All right, so let's do the math here. If we got an after-school person working with 30, which is already a lot for an after-school window, very compressed, you've got 130, 150. Let's say the average is 80. 30 of you here, 2,400 kids. That to me sounds like scale. And those two educators, the woman on the right, Dr. Lynette Jimerson, was at UC Berkeley in multicultural urban secondary ed program. This is a history, a language arts instructor for secondary, for high school kids. She's committing herself to learning how to play with circuitry because she sees this as a way to develop literacy. She works with hundreds of teachers in teacher training programs. And the woman on the left, Janine Huffman, is in the Central Valley. She's a STEM and engineering instructor, began as a CTE teacher. She too works with hundreds of kids in a design studio. And these two are a great example of practitioners who, like yourselves, are committing themselves to explore new things, to check out what's possible, and to adopt a new practice. What happens when you put circuitry and computation on paper? That's a really powerful question. Computation and circuitry we think of as in our closed boxes, our closed devices, the power of networks, the power of algorithms. That's all sitting in that little microchip. And what happens when that power shows up on a piece of paper? Ji-Chi, again, from the Media Lab, has developed these circuit stickers, and we've had the pleasure of working with her and her company called Chibitronics. This was an early prototype. But the whole question of what happens when paper becomes computationally connected is really interesting. It can look like this. This is a little flat fold-up panda. And you can make that little armature into anything you want. We'll see later on at the end, there's a little video, you'll see this thing in action. But this is a flat pack. That's about a $4 robot. Arduino is what you use to code it. There's an articulation that happens on the servo. It's a certain limit of the rotation, so you get numbers, you get armatures, you get a whole host of things. I won't say that this is a no-brainer, because this case, this is like, you want to build a house, go chop down the logs, right? You want to build a robot, solder the thing in place. So I don't want to oversell this, right? But I do want to emphasize its beauty and its delight. How do you do that? Simple little servo in the back. That servo costs $3, and it's a little small micro servo from a hobby store. It's powered, you can see it in the right-hand corner, it's powered by 3 2-volt batteries, 3-volt batteries. So now let's get a little further here. We're going to talk about coding. If you guys are looking at some of these illuminated lights around here, you're seeing a light go on and off. What is it like when you end up modulating code and you can actually work with it? This is a project done by 2 teachers. Actually, they were the instructors who taught those 2 girls. You with me? So picture a classroom, those 2 girls who were soldering and doing their own pop-up. Their instructors came through a teacher training that we did. It was a 4-hour session. And you'll see what they did here. And their project was called Robot Had a Heart. Who's programmed in Arduino here? Has anyone done Arduino programming? A few. So this is a version on a blink delay, on a blink code. So it starts with Robot Has a Heart. And here they are planning out their circuit. And ultimately, you got a circuit, you got a story. Which comes first? It's an interesting question, right? So they had a story, Robot Had a Heart, and they had to plan a circuit that would help tell that story, and we're going to go through these slides. So here they are planning out how to lay out their circuit, all right, over lunch. And there they are looking at the AT-Tiny, and you'll recall the AT-Tiny is that little microcontroller that you've seen a few times. And you have these pins, pin 0 through pin 5. And they're working out what the sequence is going to be. And there they are soldering their AT-Tiny into their notebook. So they've got a plan, right? And this is a workshop about working with this AT-Tiny. The whole room was kind of like this, filled with people doing this. And that's what the circuit looked like at the end of it. What's interesting about this circuit, I think there are 11 or 12 LEDs. Those are circuit stickers from Chibitronics. And it's all powered off a 3-volt battery. So if you tried to turn on all those, did you guys get this? Ever get it? If you try to turn on all those LEDs in one go, it's not going to work. But they made a story, and we're going to look at it and see what it does. So this is called Robot Has a Heart. Can you make out up here on the left, there's kind of a blocky shape? And in the middle, you've got sort of the heart. And on the right, you've got another blocky shape. This is a typical prototype. So what are we looking at here? We're looking at a storyboard of two robots, two robot people sort of staring across the prom floor. Pick your place where you might find a robot to be attracted to. And this was their story, Robot Has a Heart. So let's see if it'll play.
Go.
So there's some attraction. Gets very big. Sends the vibe across. And the other one picks it up. Okay? So this was the project, right? So, you know, the amount of technical thinking that went into this project is remarkable, and the amount of expressive thinking that went into this project is equally remarkable. It's a very evocative little story, two robots, and they kind of have some energy. So this was a wonderful little design, and they folded their notebook shut, they put their 3-volt battery on the side, and they went off and put it in their backpack, and off they went. And so it was a beautiful little example of a very low-cost way to get at some really complex engineering, some interesting storytelling, some really deep planning, a lot of troubleshooting, technical skills in spades, soldering, connections, the whole thing. And kids, given the chance, will jump at this. Very simple stuff, very low cost. I'm at the point in the talk where I'm going to shift a little bit to network connectivity, okay? Is that Tide notebook floating around here? The handmade book? Yeah, you've got it. So we're going to talk, that book, if you've not seen it, you'll see it shortly. We set out when we started doing this work with NextMap, and I work with NextMap. It's a nonprofit in San Francisco devoted to this paper circuitry work. We said we're living in a time when sensors and materials and our world around us, whether it's our cars, our thermostats, even within our skin, on our phones, are going to be connected. And we need to know how to navigate those systems. We don't have to look very far to understand what's happening with all the algorithms that are doing things with our identities on social networks. How do we understand those networks? How do we understand the design behind those networks? How do we think about data? We wanted to be able to pull real-time data from our communities into paper, and that's what we're working on now. So the next version of our work is going to focus on delivering this as an experience for teachers like you and your kids. It's not done yet. You can see the prototypes here. There's one there I'll talk about in a moment as well. But we're talking about creative coding. Now I'd like you to look up here. You see the word tide level? Tide level lower than 0, tide data I equals 0, tide level higher than 5 equals 5. See that? There's a really great colleague and designer named Natalie Freed who's taking the NOAA.gov information from the tidal monitor just north of the Golden Gate Bridge. You with me? NOAA has monitoring systems all over the world, and there's one sitting just north of the Golden Gate Bridge. And you can go tunnel in through an API, get that server data, view what's called JSON scripts that are all about geolocated information, and you can then render that out as a numerical value. And my good friend and colleague Natalie has been helping us think about that. How do we take computational information and make it visible? So that book you're looking at is taking the low-high range of the tides and moving it through. When it's low tide, you'll notice there are a few lights on the beach. When it's high tide, they're all the way up. And that's what we're doing here. So, you know, there's no simple way to say it, but it's a prototyping initiative that explores the possibilities of connected learning, fabrication, open data, and civic engagement. So there's no reason why we can't get this system connected to the internet in a way that allows kids to pull real-time data. It could be that they are sitting and they can design a little bus schedule so they can see it on their phone and they can design it in their notebook. It could be that there's a little sensor monitor in the hallway at the cafeteria that goes to high or low. These are smart systems that are being built already. But when I think about the interface that really compels people, if kids can design this on paper, they can fold it up and give it to their friend, that's a level of intimate connection to the creative process and to the work and the production I think is very, very powerful. It's different than only doing it on the phone. And I don't mean to say that we should throw away our phones, anything but. But the opportunity to design systems from the ground up and with simple materials and get some innate understanding of what that can feel like, and the ability to think about networks and computation that way, and craft and expression, and to personalize those things with forms and rituals and routines that we come to naturally, it's really great. I think it's a powerful way to address equity issues, cost issues, highlight creativity, address gender issues, all kinds of things if you position this work and these kinds of experience at the right point in the learning cycle. And it's especially important for teachers like us to try this out and to get comfortable with this because this is the world we live in. Okay? Another example, numbers and narrative. I talked about maps. This is a project we did with, and we are still doing with folks at the University of Pittsburgh and Carnegie Mellon, and also with Notre Dame's STEM certification program. You can see these chibi chips from Chibitronics. How many of you use Scratch or visual block programming languages? Well, maybe if you're familiar with MakeCode, which is Microsoft's version of that. The Chibi chip runs off MakeCode, and it allows you to control your outputs. And so this is an example. You're going to listen again to a teacher walk through this. This is a teacher from Arizona explaining her project. Let's just listen to her. She's very thorough.
Okay. So I decided to outline surface water in Tucson for our students because it's not something that we have just hanging around. So I chose 3 of the most popular areas that students would go to or probably already knew about to use their prior knowledge. And then I highlighted 2 areas that maybe they wouldn't know in case I had extra time to do that. So after I labeled those and marked them on my map and pushed them through so I could identify where they were going to be on the circuit board, I went ahead and lined everything up. I set my ground or negative so I could begin then placing my lights. And I started with the 3 areas in case I ran out of time that would be in color that students would be able to identify with the overlay. And then I went ahead and ran my positive connections and so I could go ahead and place my lights. And then went ahead and tested everything to make sure that it worked. And once that happened, I went ahead and said, okay, can I include the 2 outlying parks that students may not have been to and or may not know about depending on where they lived. And then I ran the additional ground if needed and positive lines to be able to do that. My concern was this one down here where the clip will go because I had to run it underneath. And I was afraid based on looking at the clip that there might be some overlap there that would prevent the current from running under. But I tried it and I tested it and it worked. So now when I chose 2 white lights to be able to do that. And when I set those up, they line up, they did. And then I put the overlay back over the top. Now I can have a conversation with students about, okay, are these 3 parks that you are familiar with, or what color?
So there you go. That's a pretty thorough explanation of a project. Another example, we're using paper. You'll notice on the side there, these little clips. We're using paper as a signal through the web to do a simple binary poll. So kids can use paper circuitry to do a yes-no binary poll. And they can pull that information out of Google Sheets or online, and that can then be pushed back to their craft. We have a thing called the Austin Data Dashboard. You can see it right here. Can you guys see this little pop-up? If anyone been to the city of Austin before? Austin, Texas? Well, you'll recognize Austin, Texas. There are 3 different, this is live. This is a live, it's pulling live sensor data from the city of Austin. Temperature is rendered, I'm getting my booming there. Temperature is rendered from here to here, 32 degrees to 110. So divide that radius by the space, you get 16-degree increments. So you guys do the math, I can't see it. You can multiply 16 times however many, and you know what the temperature is in Austin. I go to conferences and I'll set up in the morning and it'll be down here, and by then it's up to there. So it moves through the day. So you think of this as a graphical user interface that's pulling real-time data. You can see that light over the highway, that's the traffic circulation. And in the back here is kind of a colored light for green that tells us the air quality is good. So we're thinking about paper as a user interface for our communities, okay? This is a local project, which is near and dear to my heart. A colleague named Dr. Elizabeth Sylvan was maker in residence at the Krauss Center for Innovation, and she worked with several artists in residence to design this installation. Again, we're talking about spatial information about communities. And so they laid this out related to environment. And let's look at the tour here. And you can see how, and they did this with students in a summer camp. But you'll see how they're using the lights and the illumination to highlight different things about the community and about the information for their region. They're doing water, they're doing air, they're doing land, they're doing sort of urban density. And it's an installation that's designed to function the way you might showcase something in a school or at a museum. And again, it's a fully crafted display that's highly personal, highly evocative, and very situated, okay? It's very tied to the zip code. And here's another example of what we're doing. That's the very rough prototype of where we're at to kind of be able to pull information onto paper. We're using the phone to tether to the internet. So we're working through the prototyping. And then we're also doing stuff with a wonderful design group called the Wonderful Idea Company, which is in the East Bay. And we're working with sort of localized data. In this case, it's a garden. Patterns of butterfly behavior, patterns of growth through the garden, switches up there. It's a very evocative, very playful way to think of paper and electronics. The last thing I want to do, and wrapping up, is we just finished a Kickstarter. And if you've seen that little booklet I was handing around, you'll hear more of me in it because I had to talk on the Kickstarter, right? But I think it gives a good description of what it is we're doing around the notebook and the use of paper circuitry, and it's a way to wrap up, okay? So with luck, it'll play. This was the kind of comment we got. Backer number 45 from the Netherlands. It turns out you do a little research, and we had a back and forth. He's a security researcher based in the Netherlands. Jupyter Notebooks are a very powerful open source software tool. And he saw this work we're doing and thought it was a really useful thing for educators to explore, and it was great to get his support. Here we go.
There's a quote about possibility and potential from the author William Gibson. Details about the exact phrasing and when he said it aren't exact, but the version that gets shared around is, the future's already here, it's just not evenly distributed. If you're a teacher juggling resources, skill levels, technologies, demographics, trying to create opportunity and agency for kids, you know exactly what this means. My name is David Cole. I work with NextMap, a STEAM learning nonprofit in San Francisco. We're a leadership development organization. We train teachers, and we've worked with hundreds of educators across the country, from Pittsburgh to Alaska, sharing this simple idea that paper and electronics, and writing, crafting, constructing in a familiar format like a notebook, is a low-cost way to combine tradition and innovation. We're running this campaign asking for your help to get one of our projects, the Hack Your Notebook series, printed and out into the world. We designed these booklets as a 4-part learning sequence, from LEDs to pop-up to microcontrollers to servos, to help you explore what's possible with paper and electronics. If you're getting started, check out books 1 and 2. If you're ready to experiment with soldering and an introductory coding experience, try books 3 and 4. We use these booklets in professional development settings, where participants build projects in the notebooks themselves. When we started, we called this the light bulb moment, for the way it helps teachers jumpstart their understanding about what's possible with familiar materials and introductory electronics. Each booklet comes with materials to complete a unique activity created by the contributing artist and engineer. We can't wait to see where you'll go with them. Think of it this way. There are 2 platforms in every learning setting. One's a notebook, the other's a screen. One is centuries old, the other a few decades. We think they belong together. especially for teachers in upper elementary and the middle school. This is a powerful way to introduce important literacies connected with problem solving, systems thinking, and the power of technology to support expressive learning through storytelling and physical computing. Help us bring this experience to more kids and teachers. Thank you for your support.
So there you go. That was that. But you get a picture of what it is we've been trying to do. Now this, one other thing, I just want to make a plug for this. If you guys follow Make Media, this is a newsletter. I've been doing that for the past 4 months. So another one's coming out next week. So if you're following Make Media and their education side, you can look for that. And it's a newsletter I do with them every month. And last but not least, you can contact me. You guys are all local, right? And I'm local. So if you'd like to be in touch, find us any way you'd like and reach out, and we can continue the conversation. I think I may have run a little bit over, but thank you very much for your time and your attention. It's been a real pleasure. I guess if there are any questions, we could do a short Q&A. Is that appropriate? Yeah? Yeah?
Yeah, so if anyone has questions, we have time for a couple before we start lunch, but David will be here for a few minutes after that as well if you have additional questions. So if you have a question, go ahead and raise your hand, and we will bring a mic to you.
And if you don't, that's okay too. I'm going to be hanging around. You can hit me up separately. Yes, sir. What's your name?
I'm David.
You're David too.
And yeah. I'm curious what the learning curve, I teach middle school, but how long it typically takes teachers. I saw you showing trainings that were going on there to be able to use these projects.
If you think of it as sort of an introductory experience, we've done a lot of workshops with teachers just like you. And if you're trying it out for the first time and you want to simply explore the experience of working with paper circuitry and getting it into a documentation system, let's call it, as part of a poster or part of a project or a complement or to augment or extend the thinking. You've seen some of these templates we use, and we kind of improvise them depending on who we're working with. And so a workshop, we've done these with teachers, a 3-hour workshop typically sends teachers like you out the door with an idea. And as a former teacher myself, whenever we do workshops, the goal is to have the teacher make the project that they will then explore with their kids. So it's not like passive learning when you go to learn software at your district. I've done enough of that, right? So you'll come to the workshop and you'll actually complete a project. And we use a series of templates that are easily replicable. So to do some of the stuff that was relatively simple, like those little LEDs and those little experiments, 3 hours gives a person a chance to play with it, think through a design, and go and implement. If you're looking at trying to do some computation or work with the coding, it's better to have the 2 to 3:30 as a two-part. Because, as you can imagine, it's all about backwards planning and scaffolding this thing properly. If you're a CS teacher who's very facile with Arduino and coding, and you just want to get busy with it, and all you really need to know is, what are those outputs? How do those lights work? I can code that. Can I do a blink and a fade? And you meet people like that. That's a different exercise. So it's a question of where your group is. So if you're in a STEAM district, and you've got a CS teacher who's all over the visual block programming language and doing physical computing, the idea of crafted extensions is a nifty way for them to think about maybe pushing their physical computing project a little bit earlier into the grades. So they need to get comfortable with scissors and tape. If you're dealing with teachers for whom making and sort of the principles of engineering, the way NGS thinks of them, and documentation is still sort of where they're going, and they want to augment and extend through craft and materials, you can come at it the other way. Does that give you a feel? Sure. Yeah. Other questions or comments? Yes.
Or how often, I'm sorry. When or how often do you have the workshops? I come from a really small school who 5 years ago gave up paper and is doing this, but this year I'm bringing paper back because I think timelines are really important. But now I'm looking at this and I'm thinking, oh, wouldn't it be so cool to have LED lights on their timelines that they're creating? So how can I get into a workshop?
Well, quick comment. It's great people are working on devices. I don't want you to leave here thinking that devices are bad. Devices are ubiquitous. It's like gravity. We need to get better at understanding how our devices work so that they don't overwhelm us. You may have noticed in there was a picture of a teacher holding his iPad taking a picture of his project. So if you think of your iPad as the device for capturing your documentation in stages, I think all the learning goals are completely integrated and the use of the device is really appropriate. As to workshops, what we like to do is work with a teaching team. And sometimes you get sites who, within districts, there are clusters of educators. You guys already define a cluster of people who've self-selected to put yourselves into a new space outside a comfort zone. So to answer your question, if you have a cohort of folks at your school, 4 or 5 of them, if you know another school that's sort of in a similar situation that's within your district or with whom you circulate, and you could put something like that together, critical mass is great. It's really important to get as much critical mass so you can get a conversation professionally across the hallway, across the building, across sites. And that's a conversation of critical mass. An example, maybe, that might be appropriate. Grass Valley Elementary School is a making school in Oakland. Small little school up in the hills. And a lot of focus on special ed, a lot of kids with learning challenges. And they've brought in materials and making and as a fundamental part of their practice. And they brought us in and we worked with 10 of their teachers. The principal came in, sat in for the first 20 minutes, and that was sort of an afternoon from 2 to 5. Does that make sense? So, it's really a question of what your PD budget does. Materials are not a great deal here. What a nice scenario, just to play this out, is that you have a procurement budget that buys toner, right? That budget ought to be able to buy a little bit of tape and some LEDs and some batteries, right? It's not a lot of money, especially if you've got a composition book nearby and you can create an object and an artifact. We often do these workshops with this. Lots of ways to kind of collateralize and get kids making and sharing. Great little thing to do with templates. So it's very flexible. The trick is to get some critical mass among the community. Yeah. Be glad to be in touch. You can find us.
All right. Thank you, David.
Sure. Thank you all. Such a treat.